I love it. Welcome to Locali-T podcast. My name is Chris. We're excited to be here. We're chatting about air conditioning. Air conditioning is upon us, I believe, hopefully, even though it's been just winter time and fall time and springtime and summertime. It's just been all of the times.
Yep.
So how has it been out there just working on ACs, and how have you guys been doing?
Been doing good. Weather, like you've stated, just can't make up its mind. It's been getting really cold and then really hot, and so it's just a weird shoulder season right now until we finally hit, June, July, and it's consistently hot.
Totally.
And then it's just all everyone on board. You just get going.
Yeah. I think that air conditioning is such an interesting part of our culture now because you have quite a few people that remember when air conditioning wasn't even a thing. And now it's like you cannot live without it at all. So what are some of the things that, like from a customer perspective, how is it different inside of people's homes when people have no heat versus when they have no cooling?
I think there's a lot more urgency with no cooling. When it comes to heating season, if they're without heat, obviously people are upset if things are broken, it's not working, but you can always bundle up.
Sure.
A lot of people have fireplaces. A little bit easier to stay warm, but when it comes to the heat, there's really no other way to get that heat out unless you go and just get a bunch of window units, and that can just be hard for a lot of homes. And if it's already 90 degrees in there,
Yeah.
AC's been broken for how many days? People are on edge for sure, especially get new babies. It's just hot and everyone's miserable.
Totally. No, that makes sense. When it comes to the type, like the AC operation, let's maybe walk through that, because I think you hit something very interesting. You're talking about removing heat from the home. So if we were to talk through like how the AC operates, what's that sequence of events? How does the AC actually work?
Well, it's just basically from the refrigerant in these copper lines. You have a compressor in your AC unit, and it's just pumping refrigerant in a big loop. One analogy is you can think of it as a bus. There's two bus stops on the AC system. First bus stop's in the evaporator coil above your furnace. That's where it stops, picks up heat as the air is passing through the refrigerant. That refrigerant is absorbing heat, and then that bus goes outside to the next bus stop, and that's where it gets rid of that heat.
Got it.
So basically, just removes heat from a home.
Okay, so it's just gathering heat and then taking it outside. So with that kind of process, I know really we can nerd out on the latent heat versus the sensible heat and how the state change really makes air conditioning possible or any refrigeration possible. But from like a homeowner's perspective, what are the things like internal to the house that cause the heat to hop on that bus to be able to go outside?
Well, your blower motor, you have your return grills. Generally, they're on the bottom baseboards, longer, rectangle
These guys
grills.
right here.
Correct.
Yep.
And when it's running and cooling, that fan speed's pretty much maxing out, and it's sucking in all the hot air through those return grills, and then that air is getting drawn through the ductwork, gets filtered, and the blower pushes it through the evaporator coil. And it just sits there and recirculates.
So as it recirculates through, then you have the heat that's going through the evaporator coil, and the evaporator coil is absorbing that heat and it's going into the refrigerant.
Correct.
So it's hopped on that bus, and now we're taking that bus outside. What does that outdoor unit need to do with it? How does that work? What physically is happening from the homeowner's perspective outside?
What's happening out there is when the refrigerant's going through the condenser coil, there's a fan on top. So when it's warm out, there's a huge heat load in the home, we're actively removing heat. You can put your hand over that fan, you generally feel the warm, hot air. That's the heat getting brought from the home being put outside. The AC is rejecting that heat.
Okay.
So two fans. One fan is allowing the air or pushing the air to absorb the heat, and the other one is pulling air to try and reject that heat.
Got it. And with that, then let's talk about airflow again, because on the last podcast, we were talking about furnace operation and some things that cause issues inside of the furnace. So I know we hit on filtration being like the number one thing that a homeowner can do is replace their filter and make sure everything is sealed, everything is tip top in clean shape in order to keep the furnace operating. How does that filter affect the operation of the AC? What happens when the furnace filter gets super dirty?
It will allow not as much air to get through that filter. It's basically acting like a restriction. And when we're not moving enough air across that evaporator coil, it will start to freeze over because we're just not moving enough heat across it.
Totally. And so if we have air that's slowly passing through, I'm almost absorbing too much heat then, is what it sounds like.
Theoretically, I mean, that's one way to look at it, but that refrigerant is going to absorb a lot of heat. If we're just not moving the correct amount of CFM per the tonnage of the unit, we're not going to draw enough heat. If we're just not moving more air through that coil and it's just a smaller amount, we still have a lot of refrigerant that's flowing through there. We're just going to absorb too much heat, and then it's going to cause the refrigerant to drop below freezing.
Okay.
And then it'll start to frost over.
Okay. So I think a lot of times. No, that's great. I was thinking that in my experience, a lot of times people think about cool air blowing, and so it's like you almost want it to be freezing because it's like the idea is that you're taking this air and you're making it colder through like going by an ice block or going past an evaporative cooler pad or something. And so air conditioning is fundamentally different than that, correct? So with that fundamental difference is my refrigerant, it's dropping in pressure coming through my evaporator coil, which then causes that drop in pressure has a drop in temperature. And when I have that low temperature, heat always wants to move to where it's colder. So all the heat in the air is going to move from the air that we're pulling from your returns, like we were talking about, through the blower up into the evaporator coil. And if I have cold air there, or if I don't have enough heat that is there, then I don't have enough heat that is going into the cold refrigerant. Thus, I start saying, all right, let's start cooling down below dew point inside of my evaporator coil up here, creating an ice block. And that is a problem for sure. How many times do we run into that in AC season?
All the time.
All the time. Like how many times is all the time, do you think?
Okay, well, maybe all the time wasn't the best choice of words to use, but it's not uncommon.
Okay.
You're definitely going to have quite a few each cooling season where people, they have a 1-inch filter. We're already not moving enough air, and then it just, the house might be drafty, so we're getting a lot of dust clogged in that filter. And they just say, the airflow stops, it's stopped working, it's not cooling. You show up and it's just an ice block. It's pretty uncommon, or not uncommon, to have it freeze up because just filter choice from people, they're not changing out enough, or they're just setting the temperature down too cold.
Too cold.
Okay. And just the way that these systems are designed, we're comfort cooling, we're not, basically running chillers in homes.
Got it. And we were also talking about the returns and the way that the air flows in the last podcast about how my returns they're drawing air in. And so I want to strategically have these returns in places where I want to either draw cold air in the winter so that I can heat that cold air, or in the summer I need to draw hot air from the home. So what are some things that would cause the air to be too cold when I come to this evaporator coil? What are some things inside of a home that would cause that?
Well, one, you could have, if you have a basement, you could have too many returns down there and not enough upstairs, so we're consistently drawing the cooler air that's already naturally dropped down the stairs and it's sitting down there, whether it's 65 degrees or whatever. There's one scenario. The other one would just be, like I said, keeping the thermostat set too low, and we remove too much heat out of the house. Now we're just trying to remove more, and it's just not working very efficiently.
Got it. I have had some customers that have wanted their home to be at like 68, 69 degrees. And I've had some customers where that's been just like normal, like their system has allowed it to work. And then other people's systems, they've froze up if you go below 72. Where's the disconnect? Like, what's the difference between the systems, or what could be happening in those two different homes, and how is that possible?
I think I'm just going off the general rule of thumb. I mean, every system, they act a little bit differently. Sizing's huge. You got to have the system sized right for the home. Also, the type of metering device for the refrigerant. The older style, like pistons, I feel like they're a little bit more forgiving in some scenarios, because I did have one example where I went out a couple of years ago to this, it was in the summer, this kind of townhome, old R22 compressor, and the guy consistently kept his home at 56 degrees.
Wow.
I don't know how it was working. I talked with the manufacturer on that, tech support, because it was a new thing for me, and even he was baffled.
Wow.
Just kind of just chalking it up, and a lot of well, maybe it was a piston, maybe it's just this. A lot of kind of weird scenarios that allow that, but it's just not the norm.
Got it.
I've also had one system that was newer. As the systems get, or the newer systems, they get more efficient. We're trying to squeeze as much efficiency out of the equipment where we're not spending as much on utilities, and it just runs better for the home. Slow wins the race, basically. But back to my point, I did have a newer system, American Standard. They like to keep it 67 degrees in their home. And back then, I was a little bit newer. I wasn't too sure on the whole, if you get below 70, you run a higher chance of freezing. Sure enough, I hooked up my refrigerant gauges, and it looked like it was low. After I started charging it up, it got messed up. Basically, everything just went way out of whack. And talking with the manufacturer, he said it was charged fine. It just looked like that because they were below 70 degrees.
Got it.
So a lot of nuances and variables that can affect that. But generally, with these split systems in homes, 70 is a good point where you run a higher chance of freezing. Some systems just achieve it. Maybe the ductwork is just designed better.
Yeah, or it could handle a higher amount of air, right?
Yep.
So if I have more heat that's passing through it or a faster amount of airflow, then it's possible there could be some offset that happens there.
Yep.
I've heard, ACs in like a perfect world, how we would know that they're operating well just by getting one reading. And it's not well, it just means that they're operating at least in a broad spectrum of correctness, I guess is the right way of looking at it. And that is the delta T. So the temperature split between my return air that's coming down into my evaporator coil and then my supply air coming out. So if I have a 20-degree difference or a 20-degree delta, which we call delta T, then I'm removing 20 degrees of heat across that coil. Yep. I've heard that the temperature that's on the coil when we're going through that metering device through basically this little tiny nozzle that goes from a liquid and sprays it almost into an aerosol, and that pressure drops the temperature, and the temperature that is on that coil, if we get our return temperature down, to where the return is within 20 degrees of where the coil temperature is. So let's say we have 60-degree return air. My coil temperature could be at about 40 degrees. And if I drop any lower than that, if I get below that freezing point of just moisture, 32 degrees on the surface of the coil, that's when ice can start forming. Yep. How does that sound to you as far as like a good rule of thumb, or if you feel like that's accurate or not?
For the 20-degree delta T, that's what we've always went with. I think it's a pretty good general rule of thumb, because obviously you can have some systems where even if you have a 20-degree, there's issues going on with the refrigerant, whether it's low or there's airflow issues.
Yeah.
So it's just more of, general rule of thumb, but as a technician, you're also aware of everything else. It's not just, okay, 20 degrees, and I'm going to ignore the fact that there's all these other issues here. There's oil all over this. It's just, that puts us in the right direction if everything is looking pretty good. Everything's checking out. We're not seeing visual signs of issues, and we get a 20-degree and the customers have never complained about any issues. More than likely, it's good.
Got it.
So we do feel like it's a good general rule of thumb. You just got to be smart with it,
Yeah.
Open your eyes.
That makes sense. I remember there was a call I went to, and we had a decent delta T. It was like, 17 degrees, and I know there's a range, and everybody has their own range of what's acceptable, and it depends if it's two-stage or what elevation you're at or what type of static pressure. And there's a level of nuance on balancing the right amount of airflow through the coil from a tonnage volume perspective, and how much I'm removing, and then how is the outdoor unit positioned, and is it clean, and can I remove the heat from it? And I remember seeing a delta T that was like I said, about 17 degrees. And so I was like, okay, cool. Went outside, started cleaning the condenser off, went back in to hook up all of my final checks, and the AC immediately started freezing. And that was a learning point for me, because I realized that if not everything is clean and if my airflow isn't set appropriately to begin with, then that delta T doesn't really matter much anyway.
Yep.
And what was happening is the outdoor unit was so compacted with dirt and debris, it was keeping my pressure high. So I was doing something, but as soon as I cleaned it, my pressure dropped.
Yep.
And it caused it to freeze. How best would you walk a homeowner through explaining that? If somebody's had a homeowner come in, or a homeowner has had a technician come in, system was working fine, we clean it, all of a sudden it's freezing. How do you explain that?
One way I like to explain is just when I talk with homeowners, we're in cooling season, we're dealing with refrigerant issues, and it comes down to there may be a refrigerant issue or not, and we've got dirty components all throughout the system. I always just like to keep it as basic as possible and just explain, surprisingly, believe it or not, your AC is only removing heat out of the home, and we can only do that if airflow is correct. I like to tell them I could put a dirty filter into your system, and I could hook up my gauges, and it would tell me it's low all day long, just because we're not grabbing enough heat.
Got it.
And that's the most honest way, transparent way I felt like has been able to do that. Just telling them it's all down to airflow. We are removing heat out of the home. If anything is off with the airflow, the readings are going to be off when you're doing your refrigerant checks.
Got it. So airflow, back to airflow. I mean, it just seems like everything is around that. I know we talked about how important airflow was for heating on like a scale of which one's more important. What would you categorize as like the most important appliance to ensure that airflow is correct for? Is it the furnace or is it the AC?
Well, I mean, it's a good question, because I put them both up there at top importance. I feel like there's not one that's better than the other, because there's a lot related to with the furnace that we have to have correct airflow to protect that system and make it last as long as possible. And then also same with the AC, we have to have the correct amount of airflow.
Got it.
To keep it from freezing over, potentially damaging the electrical components inside that unit when it thaws over, and the compressor. So airflow, I would say, is just, it's neck and neck. It's just critical to make sure it's set 100% properly for furnace and AC.
And why is it that we're needing to set this? Like, if we know it's a 3-ton AC and you have a furnace and you hook them up, why is it different here than it might be in other places? Why is this such a specific thing that you have to set?
Well, I mean, altitude plays a part. When you're setting gas pressure, you got to set the airflow correctly for that. And also just for here, we're about 450 CFM per ton, because we generally oversize our evaporator coils. And we're just not dealing with a lot of humidity. So we like to stay, I mean, you could be between 400, 450 CFM per ton. So if it's a 3-ton coil, you just multiply that, and that's where you want to stay. And then, getting kind of nitty gritty with the airflow, you want to make sure your ductwork sized correctly. We are allowed to move the proper amount of air, and then also verify with your gauges, the refrigerant pressures, that everything is having a happy relationship.
Got it. I know it's been really common in our industry to change the size of equipment, where maybe you had a 4-ton unit, then somebody comes in and says, hey, it's oversized, we need to shrink this piece of equipment, or vice versa. Hey, this was always undersized and it needs to increase. And it seems like there's a lot of homes that have had that happen. and then they just haven't worked very well after that size change has happened. And I know there's frustrated people where, this is supposed to be more efficient. It's running longer. It's not keeping up. It's not as cold as it used to be. So what would your reaction be to that? Why does that happen in our industry?
It makes sense. There's a lot of companies out there, utility companies, that come in and blow in extra insulation. People get their windows sealed. So an older home that was drafty in the past with a heat-only system, they were just trying to move as much heat as they could because of the amount of heat loss that was occurring. And now when we're not having as much heat loss, you don't need as big of a system. And then also when it comes to the newer equipment with how it's designed and it's running slower, I'll go back to your analogy that I really loved. Slow wins the race, like I always say, but when you have a jar of oil and water and you shake it vigorously really quick and then stop, it separates pretty quickly. But when you're doing a slow shaking and you're doing it longer and you stop, the amount of separation isn't as quick. It starts to separate, but it's not as fast. So you won't feel as much as frigid air coming out of your vents or as super hot air coming out of your vents, because when it comes to slow wins the race, we are trying to condition the home, get air mixed properly and slowly get it drawn through the system, and get humidity pulled out of the home during the summer or add humidity during the winter. And the slower that we can run that, it allows it to penetrate more areas better, I feel like.
Like more of a longer runtime, less velocity type situation. Yep. So it's not blowing as hard through the vents, but it's running longer as far as a length of time. Yep. But that should correlate to like a bill drop as well, though, you would think. Just because I don't technically need as much energy to be consumed if I'm, let's just say, using 50% of my capacity. I'm not needing to run as hard and I'm running longer. I'm eliminating a lot of the starts and stops of these motors, which arguably that's where 90% of your wear and tear comes from, and where you have a big jolt of energy that you're drawing quickly. And so I think it makes sense a lot too. The one downside that I've heard is how do registers potentially play into this? And the reason why I'm asking is because I know that when we have a higher velocity of air, we're disrupting the hot air that's up on the ceiling. And when I drop that velocity, I'm not disrupting as much air. And would you get some more stratification inside of that box or your room, do you think?
Yeah, that's a good question. I mean, it comes down to duct sizing as well, because technically those vents are only, that heat run for that specific room can only move a certain amount of air. And if it's sized properly, we should always be moving that amount of air. But yeah, of course, having more velocity is just going to disrupt it faster. But I feel like it just won't mix as well.
Got it.
Just a jolt of hot air, feels good for a minute, and then it just separates, and the cold air instantly is dropped, and the hot air's rose again, and the thermostat's again calling for heat or cooling.
Totally. And I think to link back to what we were talking about on the returns, most of the returns that are inside of the home are right down on the floor, which is if I have less velocity coming from my registers, then I may be not throwing that cold air as high. And if I'm pulling that cold air back into that return, then I could be lowering my return temperature, which could cause freezing. Yep. So what could be something that a homeowner could do to draw the heat actually from the home, even if they're dropping in their airflow?
What I like to do, even in my home, I tell all my customers, is the newer equipment, the blowers that we have now since, I believe, 2021, they're more efficient with how they operate. Turn your fan to on and constantly circulate air. And the reason why I like to do it in my home is you have a upstairs main level basement with returns in every room. When the AC or furnace isn't running, hot air is naturally going to rise, cold air is naturally going to drop. As we're running the fan at a slower speed, we're constantly drawing in cooler air and hotter air, bringing it to the system, remixing it, and then redistributing it. So it creates more even temperatures.
Got it.
All the time.
I like that. Another hack is like the way in which returns are actually made. So like we have two returns on this, two return registers on this return here, and one is lower, one is higher. And this isn't how it's going to look inside of anybody's home, but we would see a return on like the wall behind you. And it would be, probably about 30 inches long and about 8 inches tall. And what it's doing is it's pulling the air into the joists to draw back to the furnace. And they have it ducted in the basement to where they're all connected, to where all of those white vents are connected into this return here. And since most of our 2x4 homes, those 2x4s run straight up and down, and most often they don't necessarily have headers in between every single 2x4. So what I've seen some people do is if you use a stud finder to make sure you don't have a header in the middle of your wall, if you have a return on the lower half of your wall, you can cut a hole that's the same size and put a return on the upper half of your wall next to where the ceiling is. And then you can get a magnet from Amazon or Home Depot. And in the summertime, you can put a magnet on the bottom of the register so that now I'm drawing all the hot air that's off the ceiling and I'm bringing that all the way back down to my return to get the heat actually absorbed into the evaporator coil versus trying to run and we still want to run the fan because we want to mix the air more evenly. Yeah. But now I know that even when I'm calling and cooling or if my fan is mixing, I'm actually pulling the hottest air inside of the room back to my home rather than just the cool air off the ground. Yeah. And inversely, if in the heating season, we do want the cool off the ground. So I can just take that magnet, I can slap it up on the top one, and now I'm pulling all the cold air that is needed off the floor, and I'm using that stratification of temperature actually to increase the efficiency of the air conditioner. Yeah. How do you feel about that strategy?
I think that's a good strategy. It makes sense totally, because if you're pulling where the hot air is being, where it's existing, because the cold air is naturally going to drop, it's going to be colder on the floor. I think that's a good way to go about that.
I don't think many homes have that. I think it's an easy homeowner hack to do just to help with drawing the heat, because that's thermodynamically how it's working. I'm trying to absorb heat and take it outside. Yep. So if I can strategically grab where my heat is, I have a better chance of actually shortening some runtime, because I'm not trying to remove heat from 68 degree air. Yep. I'm removing heat from 75 degree air. And that allows me to actually achieve us getting rid of the heat from the home quicker. Now, if homes don't have that, and the AC is cycling on and off, and we have, let's just say the refrigerant's fine, but we have a lot of on and off that's happening inside of the system, what's the threat for the particular parts, like the condenser and the furnace? What is physically happening that would threaten the homeowner for having it cycle on and off more often than it should?
It's just going to shorten the lifespan of the equipment. Turn on a light switch just constantly, it's going to lower the life of that light bulb there. And with a furnace already, the average cycle rate during our winters here, obviously there's variables. Some people like it set to 80 degrees and some people like it set to 60. But average is about 7,000 times each winter. So 7,000 times we are getting a call for heat, and all the relays, electrical, everything's kicking on and running, heating up the home, and then it's shutting off. And it's just doing that many times. And the more cycles you have, if say filters are dirty, now we're going to create short cycling because it's not running properly. We're tripping safeties. We could double the cycles, and which could halve the life of the unit.
That makes sense. And what about on the outdoor unit? What components see that wear and tear?
Definitely. You're going to have your contactors, just like a switch for the condenser. Thermostat calls for cooling. It basically turns on the switch out here. That contactor's constantly opening and slamming shut. You got a capacitor that's always getting these motors spinning in the right direction, help getting them up and going. And then the compressor, the fan motor, they are all just jump starting all the time.
Got it. And these motors, is that a problem that they're jump starting all the time? Like physically how they're made, aren't they made to handle that? Or why is that an issue?
I wouldn't necessarily say it's an issue that they're kicking on all the time, because ultimately you're not going to have an AC that starts running whenever your heating or cooling season starts and doesn't shut off until the end of it. we're going to have that on and off. So they can take some of that beating. It's just a matter of how we're creating an environment to cause it to do it more so often.
Got it. So 10-year parts warranty is on most systems. So arguably, we're sure the manufacturers have tested these to a point where they're pretty confident that, after 10 years, you shouldn't, as long as you have a certain number of run times within that 10 years, it shouldn't necessarily break down.
Yeah.
But inside these motors, they're all made very similarly. You've got your rotor, you have your bearings, you have your winding, you have, a run capacitor, maybe a start capacitor, but you have different components inside of the motors. What happens to these motors specifically if they're not starting very well, or they're not getting the appropriate voltage? What happens internally to those motors?
They're going to get weaker. Those windings are insulated. They're going to draw more power, to try and get up and going. The amps are going to increase on it to try and just get running. It's just constantly drawing more power. The insulation is going to wear off in the windings, or we're just going to get a short, because over time, when we're drawing more power consistently, and when you're drawing more power like that, they're also probably having heat being generated as well. So just don't go together very well.
I think what you said about the heat was a key point for me, because thinking about how these windings are created, you have these hundreds of feet of a very, very tiny copper wire. It's almost like fishing wire. It's wrapped around all of these different iron cores inside of this stator, is what we call it. And it creates an electromagnet that it makes the rotor, which is the internal part, actually move in the direction and at the speed that we want to. And we can adjust that based on the phasing of the motor and of the voltage that's applied, and et cetera. And what's interesting is that since this wire is completely hundreds of feet long, if you wrap a wire around itself and you measured continuity, it's going to be a direct short, because the electricity is just going to jump across those two little wires that are resting on each other. Yep. So these hundreds of feet of this little tiny wire is just covered in a little tiny plastic coating, so that the electricity has to go all the way through all of these different windings and then land back on the common and go back, and that's how we create that voltage. Yep. So when we have heat that is being caused through amp draw or something else that happens, if I have that little plastic, that coating that's just on that wire, and it starts melting, and I have two windings short, what happens inside of that motor?
It dies. It just will not run. You might get sparks, you might get smoke, might have black scorch marks around it, and then just trip the breaker, because it's just that power is just directly shorted, so that motor will do nothing.
Got it. So what can we do, or what can a homeowner do, or what would they ask a technician to do to prevent that from happening? What would we want the technician to look at if we're talking about the compressor and the fan motor? What would be the two items that we could look at to kind of help ensure that future doesn't happen for the customer?
When you're going through the basic checks, you want to make sure the capacitor is obviously within the tolerance rating that is of the manufacturer of the capacitor. I mean, it could be 0.5% plus or minus, or 6 or 7. You want to make sure the capacitor is within tolerance, because that is ultimately what gets that motor going up in the right direction and actually working. Make sure we have tight connections off the contactor itself, the capacitor, because if we don't have tight connections, we're also generating heat there. We want to make sure the motor itself hasn't started leaking oil, because it's a sealed bearing system. If we start seeing oil, it's just a matter of time. Once we lose the lubrication off that motor, it's going to seize up.
Got it.
So just going through and checking the electrical, getting the right power, strong connections, capacitor is good, contactor is clean and not burnt. Those are good ways to ensure that we're going to protect the equipment throughout the summer.
Got it. And lastly, from a homeowner's side, what are some things that the homeowner can do probably from like a maintenance perspective, that would just help it run a little bit more efficiently, and they can get some more lifespan out of it without necessarily needing to spend thousands of dollars or hundreds of dollars or whatever to have a professional come out. What would be some things that they could do in their scope of work that would be safe and would be something that would be positive for the unit?
Okay. Couple things is, if you have dogs, specifically male dogs, try to get a fence around it, because when they will urinate on those coils for some reason. They're just attracted to it, and that whatever's in the dog's urine will just destroy the coil, and it will cause a leak. So you want to keep the dogs away from it, keep hedges, shrubs away. We want, I think, 3 feet away from the coil so we're getting proper air through it. And then also we want to keep that coil clean. So if you live in a cottonwood area, a lot of cotton's getting a blanket around that, we're not going to be removing heat like we should. The pressure is just going to increase because we have too much heat in the refrigerant. Bottom line, we want to keep that coil clean every single year. Even if it doesn't look super dirty, you still want to rinse it. Just because there could be dust that gets clogged internally inside of it, just coats the fins, reduces the efficiency. So I'd say if the unit's not running, a lot of homeowners will elect to spray out the condenser coil themselves. Don't want to use a pressure washer. Just a soft spray of water on a downward angle, just to try and rinse all the debris off of that. Those would probably be the best things they could do to keep it lasting as long as possible. Obviously, professional maintenance is always recommended, because we could be looking at that coil, and a simple rinse isn't going to cut it.
Yeah.
We need to get some chemical in there and really clean internally through those fins to allow air to come through.
Got it. That makes sense. And how about inside? What are some things like internal to the home that they can do to help make sure that the AC is running as efficiently as possible and that you're not going to run into unnecessary breakdowns?
Change the filter. That's probably number one. Always just stay on top of your filters. If you pull out your 1-inch filter after about a month and it doesn't look super dirty, just change it out. Because even though it doesn't look super dirty, there's debris on it that's restricting air. So changing filters, not setting your thermostat too low, making the unit run or overwork itself. I always like to tell my customers, don't close off your vents. You want to keep them all open, because that system, whatever ductwork you have there, is designed to carry the amount of air that the system needs. If we shut off half those vents, we might get a little bit more velocity out of other vents, but what we're doing is creating back pressure. That air, it's just getting colder and colder. We're not moving it properly. And in return, we'll create kind of a slow downfall of the equipment. So definitely filter is number one. Don't crank your thermostat to extremes. Keep your vents open, returns clear. We don't want to put couches or entertainment centers in front of the returns. It's heavily important. It's an expensive component in the home that honestly I don't think a lot of people are aware of until they finally have to face the reality that their system it's done. There's no repairs left for it. And then they realize how expensive it really is to have to get your HVAC replaced.
Got it.
Essential component in the home today.
Got it. That brings a great question. So pretty much not every home, but a lot of homes that I've been in have the exact same problem in the exact same room inside of the house. And I like to call it the frog room, which is the freaking room over the garage. And it's just as hot. Like we don't have the insulation underneath it. A lot of times it's on a corner, so you have more exterior walls than you would have on a different internal room. Yeah. And the way in which people build homes, we probably don't have the right amount of return for that space. We probably don't have the right amount of airflow coming into that room. So if that's a problem, is a new AC unit really like the best option for you to do, like to fix that particular solution?
When it comes to, with your AC in your home, if you update your AC, maybe if you say, I'm going to oversize it because we got this one room that's just way too hot all the time, you're not going to do any benefits to yourself. You're going to spend a bunch of money for no reason, because now we just oversize the equipment and it's just not going to run efficiently. The best case scenario for that is to add a separate system for that room. Because that room, just due to where it's at and the heat load on it, it's going to be almost impossible unless you have
You redesign the ductwork, right?
Yeah, and have it super professionally done where it's done right. That just doesn't happen, really. Get like a mini split. You know, you add it up in that room, and there's no ductwork involved. It just serves that room alone. And those mini splits are really efficient with how much heat they can remove, and they can actually work pretty well below 70 degrees. You know, we deal with a lot of server rooms, and they want to keep the server rooms pretty cold because all the equipment. And I have seen them, you know, a lot of times 65, 67 degrees, and those units just crank all year long.
Interesting. I think it's been a good solution for some people too. So key takeaways, I guess, is that there are some things that homeowners can do to ensure that they can increase the longevity of their system without necessarily being reliant on an HVAC company. Always recommend, you know, not just because I am part of an HVAC company, but I do always recommend to be safe. And if you don't know what you're doing, don't go poking around in electrical. You know, capacitors are not fun to get shocked with and cause deaths every year. So, but if you feel comfortable spraying off the outdoor unit, ensuring that you don't have the stuff around it, replacing the filter, keeping registers open, maybe moving a return so that you have a high return and a low return, and cover the low return so we're pulling all the heat off the ceiling, and then maybe looking at more of a mini split to help remove heat from that area of the home. Those all things would be good for the longevity. And I've seen a lot of customers, sometimes you're just overcooling your entire home to get that one room cold. And so if you can reduce the amount of time that you're needing to spend cooling the rest of your home by strategically cooling the space that you need, saves you money in the long run, cuts down on repairs, cuts down on you know, utility costs, like I was saying, and it gives you the accurate temperature that you need. So is there anything else that you think would be important for homeowners to know or people to know in general about air conditioning, since we're coming into that season here soon?
Get it checked. That's the biggest thing. You always want to get it checked, make sure things are clean and just running properly. That way we could solve a minor issue today instead of letting it progress and turn into thousands of dollars worth of issues. That's a piece of advice I would give. And then also going back to the cleaning the condenser coils, a lot of people do it. I don't want to tell people not to. It's just you got to be careful. If the unit's running and you're spraying it, you're not helping the unit at all. That's not good. It's turned super efficient at that point, just by the amount of heat that's getting pulled out of it. But also, due to some designs on these units, there's areas that you can spray even though it looks all enclosed, but water will spray into the electrical compartment. If you have live power there, you're going to short something out. You just got to be really careful with doing it. But almost it's always recommended just to have a professional out to, you know, really look at your system. You know, be a doctor for it.
Yeah, if the goal is not replacing the system like too early and squeezing the most life out of it, keeping it as insanely clean as you possibly can and being up on the filters is probably the best way that anybody can physically in their home, you know, make that change. And then I'd argue the second thing for air conditioning is you got to pull heat from where the heat is. If you're just pulling cold air from the basement, you're going to start causing your compressor to have issues just due to not having enough heat. Like let's run the system in the specs that it should, and not try to just pull cold air. Let's pull hot air from the home. So I think that's really been all encompassing. So I hope that's helpful. So thank you so much for going through all of this. And
thank you.
This has been Locali Podcast. We really appreciate you guys tuning in again. We're here in Utah County and Utah and down in St. George. And we're looking forward to serving you guys or answering any questions that you have. Have a wonderful afternoon. Rock on. Let's go.